Paper number 2, applied paper. I'll start from the beginning. Part A, question number 1. You do with me, yeah? You do with me. Question number 1. Here, time velocity, train moves with uniform acceleration. Here, equal distances, S, time duration T1 and T2. Take here velocities V1, V2, V3. Here we have successive displacements. Here. For such case, you write relation for this displacement S equal, here this trapezium area, half into T1 into V1 plus V2. Then V1 plus V2 equal 2S divided by T1. Then second displacement S equal half into T2 into V1 plus V2, V2 plus V3. Then V2 plus V3 equal 2S over T2. Then if we have successive displacement, you subject velocities, then subtract them. 2 minus 1, V2 plus V3 minus V2 plus V1, 2S over T2, 2S over T1. Then V3 minus V1 equal 2S, T1 minus T2 over T1, T2. Here velocity gap, here velocity difference here. Then acceleration in tan alpha, V3 minus V1 over T1 plus T2. Here V3 minus V1 over T1 plus T2. Then 2T, T1 minus T2, T1, T2, T1 plus T2. Here acceleration relation. Do with me, Do with me. That is question number 1. Then question number 2, system of pulleys part. Then here, 60 inclination, 2 particles. Here A, 10G, here B, 5G. Reaction R2, R1, tension T. Now here fix acceleration F. Take acceleration F. I'll put this on other side. Along string, same acceleration F. Then use F equals ma. Then you can find the values. Okay. Continue. Okay, then F equals ma. Capital A, this way, T minus 10G sine 60 equal 10 times acceleration, a plus minus F. B upward T minus 5G sine 60. T minus 5G sine 60, 5F. Then take here 1 and 2, 1 plus 2. 5G sine 60 root 3 over 2, 15F. Here 3. Root 3 g divided by 6. Root 3 g divided by f. System of Pulik action. Just use only f equals ma. Just use only f equals ma. That is question number 2. Do with me. Do with me. Okay. Okay. Then question number 3, 4 අපි කලින් කරලා තියෙනවා. පේපර් එකේ ඩිස්කස් කරපු එකක් නම එතෙන්ට එන්නේ නැහැ. question number 3 and 4 කලින් applied paper එකේ exam එකේ තිබුණ එක. Then question number 5. Question number 5. Here I haven't done still collisions and impact and impulse thing. But anyway, this can be done using just physics. Then I'll do this one. Here, 2m. Here release height simple h. Then take this velocity v1. So when it moves downward simple h displacement, you take velocity v1. Take velocity v1. Take velocity v1. Then downward v square equal u squared plus 2as. Then here v1 square 2gh. Then v1 equal 2gh root. So when it moves downward simple h displacement, here the velocity. So now it become taut, no? So when it get taut, there will be jerk j. We call it impulse. Then instantly its velocity will change. Here initially v1, then it changed to v2. Then upward v2, like that. Okay. So instantly velocity will change. Along it's in always same velocity. Then I equal delta mv equation you can apply. Then use I equal delta mv. Here simple m, here 2m. 2m. Then simple m downward. Then don't consider about forces, huh? Just only consider about jerk. Minus j equal m, v2 minus v1. Then 2m upward, j equal 2m v2. 2m v2. Okay, then here first equation, second equation, 1 plus 2. Here 0. 3m v2 minus mv1, 0. Then v2 equal v1 divided by 3. 2gh root divided by 3. Here the velocity. Okay. Now velocity when it after the jerk, it velocity same velocity along stream we get same velocity. Along stream same velocity. Okay, that is question number 5. Do with me. Do with me. That is question number 5. Okay. Question number 6 we have done before. Question number 7, simple harmonic question. Then for now I am not doing that. Then question number 8. Question number 8. Here ABC triangle, equilateral triangle, ABC 60 degree, 60 degree. Here take B, here take C. Then AB, BC, CA forces P, 2P, 3P. These are the forces. Now here we need to find magnitude, direction and the line of action of the resultant. Then resolve horizontally, x equal P cos 60 plus 2P cos 60 minus 3P cos 60. Minus 3P only, no? Then cos 60 half, then minus 3P over 2. Then vertical forces y, here P sin 60, 2P sin 60, minus P sin 60. Then minus root 3P over 2. Then horizontally 3P over 2, root 3P over 2. Then find the resultant magnitude and direction. Then take R here. R equal 3P over 2 square, root 3P over 2 square root. Here root 3P over 2 common. 1 plus 3, 2, 4. Root 3P. Then alpha value, tan inverse root 3P over 2 over 3P over 2. Then 1 over root 3, it is pi divided by 6. Then resultant direction, pi divided by 6 to the horizontal. Then line of action, you mark resultant somewhere here, downward root 3, P over 2, let's mark somewhere here, root 3 P over 2, 3P over 2. Take here this length, simple B. Then system, moment about A anticlockwise equal resultant moment about A anticlockwise sense. Let's take clockwise sense. Then system moment, you can forget these two forces. Then 2P divided by its perpendicular distance, here A sin 60. Resultant moment, root 3P over 2 times, here perpendicular distance B. Simplify. B equal to A. Here line of action. Line of action of the resultant. So to find line of action of the resultant, take moment. Take moment. Okay, complete up to that. Complete up to that. Okay. Then question number 9, probability, later we will do that. Question number 10, statistic, later we will do that. Question number 11, part A, B, we have discussed before. Question number 11, part B, A, both we have discussed before. Question number 12 also done. Okay. Then I'll move to question number 14, part B. 14, part B. I'll සමහර questions මේ පේපර් එකයි අර කලින් ඔයාලට මොක් එක්සෑම් එකේ අපි ලියන පේපර් එකේ සමහර ප්‍රශ්න සමහර තැන්වල රිපීට් වෙන්න පුළුවන්. ඒකින්ද මම මේ ටික වැඩි ඩිස්කස් කරන්න යන්නේ නැහැ. මොනවා හරි ප්‍රශ්නයක් තිබුණොත් ඒ ටික අහන්න කතා කරලා. Okay, question number 14 part B we haven't done before. Okay, then 14 part B. It is simple question. Uniform rod. Here inside sphere, a uniform rod stay like this. Mark all forces. Here frictions. Weight W. Here resultants. Here angle of friction lambda. Here angle of friction lambda. Here subtended angle 2 alpha. Then here one angle pi minus 2 alpha divided by 2. Here pi minus 2 alpha divided by 2. Pi over 2 minus alpha. One angle pi over 2 minus alpha. Okay. Then consider this triangle, apply cot theorem here to the horizontal angle theta inclination. Now consider here theta 90 minus theta. Here this angle pi over 2 minus alpha plus lambda. Pi over 2 minus alpha plus lambda. So I'll couple these two like this. Then here this angle pi over 2 minus alpha minus lambda. Pi over 2 minus alpha minus lambda. Okay. Then you couple these two. Then ratio 1 to 1. Apply cot theorem directly. Apply cot theorem here. 1 plus 1 cot 90 minus theta. 1 plus 1 cot 90 minus theta. 1 cot 90 minus alpha plus lambda. One cot 90 minus now 2 tan theta, tan alpha plus lambda, tan alpha minus lambda. So by using just only cot theorem, you can get the result. Do with me, yeah? Complete. Complete. Okay. Then question number 15. Question number 15. Here regular hexagon. A, B, C, D, E, F. Regular hexagon. Then forces are given. Here forces are given A, B, B, C, C, D, D, E, E, F, F, A. 3P, 7P, P, 2P, MP, NP. Here inclination 60, 60-degree inclinations. Now first case, if all the forces reduce to a couple, now here the system reduced to a couple. So if the system reduced to a couple, R0, G0, G not equal 0. Then resolve horizontally, take X value 0. Here 3P minus 2P, 7P cos 60, P cos 60, NP cos 60, MP cos 60, 0. Then here P, 7, 6. 0. Here 3, 4P, N over 2 minus M over 2, 0. Then M minus N equal 8P, 8. First relation. Then second relation, vertical forces, Y0, 7P sine 60, P sine 60, MP sine 60, NP sine 60, 0. Then here cancel P, cancel sine 60, then M plus N equal 8. Then solve simultaneous equations. 1 plus 2, 2M 16, M 8. 1 minus 2 minus 2N 0, N 0. May Mn values taken out. Solve simultaneous equations. Okay, complete. That is question number 15 part A, first part. Okay, now these are the values of Mn, but here you need to show that there will be a couple. With these Mn values, the system says that it is a couple, no? So we can only consider about xi only, x equals 0, y equals 0. These all values are possible with equilibrium condition as well. But first one, that reduced to a couple, no? Therefore, you find moment about here O, take moment about O. Then for each case, perpendicular distances are same. Here 60, no? Side regular hexagon, side not given, you take side 2A, side 2A. Then here equilateral triangle 2A. Then all forces perpendicular distance same. Then 3P, 7P, P, 2P, MP, NP, perpendicular distance here 2A sine 60. 2A sine 60. Now 10, 11, 13. M 8. Therefore, R equals 0, J not equals 0. When මේ point එක ගොඩක් කට්ටිය පේන්නේ නැති වෙයි යා. ඒ කියන්නේ couple එකක් කියලා අපි mn මේක equilibrium කිව්වත් ඕකම තමයි එන්නේ. mn එක. ඒතර couple එකක් කියන එක double check කරලා verify කරන්න ඕනේ. නැත්නම් ඒක ලකුණු miss වෙන්න ඉඩ තියෙනවා. එතන verification එකක් තියෙනවා. Okay. Continue. Now here second part. Second part. If the system reduced to a single force along AD, resultant passing through AD. Now second case, resultant passing through AD. Therefore, moment about any point on this line will be 0. Moment about any point on the line. Therefore, about a moment, second part, GA 0. Then here 7P and MP perpendicular distances are same. Here 2A, here 60, 2A, then this will be 2A sine 60, this also 2A sine 60. Then I'll do at once 7P plus NP, 2A sine 60. Then you can forget 3P and NP. Here this is MP, no? MP. Then P, 2P, same perpendicular distances. A sine 2A sine 60, 2A sine 60, 4A sine 60. Then P plus 2P, 2A sine 60, 0. Okay. Then here perpendicular distance 2A sine 60, 2A sine 60, 4A sine 60. 4A sine 60. Yeah. Now simplify. Cancel P, cancel A sine 60, cancel 2. 7 plus M, 3 into 2, 6. m equal minus 13. Minus 13. Okay. Then about O moment, G also 0. O moment also 0. No? Resultant passing through AD. Therefore, about A moment, about O moment, about B moment, all are 0. Then you take here about O moment. All perpendicular distances are same. No? Then here you can take this relation. 3p, 7p, p, 2p, mp, np, 2a sine 60, 0. Now simplify. 10, 11, 13. M plus n minus 13 plus n 0. Then n value 0. N value 0. M value minus 13, n value 0. N value 0. The system reduced to a single force passing through AD. That is second case. Huh? Complete. We have two cases, two simple cases. Okay. Then question number 15, part B, Bose notation question. Here, take this diagram. F 45, 45, 45. මෙතන මේ question එකේ පොඩි error එකක් තියෙනවා. මේකට hinge එකක් දාගන්න මෙතන. මෙතන පොඩි hinge එකක් දාගන්න. මෙතන error එකක් තියෙනවා නැත්නම් හදන්න බෑ. Okay. 2F. A, B, C, E, G. Then your reaction are about A moment. Take about A moment. Then F times. You take length simple A. 2F times. Here A 2A. R times A 3A. 0. Now simplify. For 5, R equal 5F divided by 3. 5F divided by 3, R value. Then F given 3 kilonewtons. 3 over 3. 5 kilonewtons, R value. Then we need to find stresses. Here take boundary line. Here 5 kilonewton. Here F equal 3 kilonewton. Here 6 kilonewton. A, B, C, D, E, F, G, H. These are the regions. Here we need to find axial forces of BC and BE. BC and BE. Axial forces. ඒ කියන්නේ stresses වල අර දෙක විතරයි ඕනේ. Okay. Then start from here. AB downward. Here AB. BC double. CD 5. Here 3, 2, 5. 3, 6, 5. This somewhere here. Then rotate about this. DE. EC horizontal. Then come to here. DF horizontal. FE vertical. Then come to here. FG. GB horizontal. Then go to here. DH. DH. HG vertical. Then HA. Here it is. 45 degree, 45 degree. Now here, this case we need to find BC and BE only. Here B, C. BC and BE only. Then GF. FG. This way. then GH downward. So we need to find these two stresses only. Therefore, BE tension here tension and BC thrust. Tension and here thrust. Then here 5W, here W 1 kilonewton. Then here 1 kilonewton, 1 kilonewton. Therefore GH 1 kilonewton, here 1 kilonewton, then GF root 2 kilonewton, root 2 kilonewton. Therefore BC thrust 1 kilonewton. Here BC thrust root 2 kilonewton, root 2 kilonewton. Okay, complete. No need to find all, no need to find all. Huh? We just need to find only two rods. Complete. Complete. Then question number 16. Question number 16, center of gravity question, simple question. Here it is not given to find center of gravity. Okay. අපි තාම මේක proof ටික කරේ නැහැ. ඔයාලා just මේක apply කරගන්න. Question number 16. Here arc, semicircular arc. Then center of gravity somewhere here. Radius simple r, no? Radius simple r. Then here take x bar. X bar equal, we know r sine pi over 2 over pi divided by 2. R sine alpha over alpha center of gravity. Then 2r divided by pi, here x bar. So when it is suspended at this point A, then center of gravity and the suspending point will be vertical. Now we need to find new inclination AB to the vertical. Here AB to the vertical, here theta. Then tan theta, x bar divided by r. 2r divided by pi. Then theta, tan inverse 2 divided by pi. Here this is inclination, first case, AB to the vertical. AB to the vertical. That is the angle. AB to the vertical angle. You find center of gravity and suspending point and center of gravity, join it. Then here this will be vertical line. This will be vertical line. Then you find inclination using just geometry. Complete. Okay, then next case, a particle equal to weight of the wire now attached to the end B. Find new inclination AB to the vertical. Now here it is. Here weight W. Here point A, same weight W attached here. Then here 2W resultant at the midpoint. Now center of gravity goes to here. Here previous center of gravity, now here new center of gravity. Equal weights now. Equal weight W, then resultant 2W at the midpoint. Therefore, when you suspend at A, then A and G will be vertical. No? A and G will be vertical. Now, here this will be vertical line. Now, inclination of AB to the vertical, you need to find this angle theta. You need to find that angle. Now, here this length we know, and this length again we know. Here this one, x bar 2r over pi, no? 2r divided by pi. Then here this part, half of that, r divided by pi. Half of that, no? Angle, here midpoint, no? Then here these two, half, here this length, half of this one, no? Midpoint theorem. Now, here again bisected, here this length r, here r divided by 2. Therefore, now write alpha, tan alpha, here r divided by pi, divided by here r plus r over 2. Then tan alpha, 2 divided by 3 pi. Alpha tan inverse 2 over 3 pi. Tan inverse 2 over 3 pi. Now here the inclination to the vertical now. So initially we had W, then another particle of weight W attached. Then by these two, midpoint will be new center of gravity. Find that one. Then center of gravity and suspended point, join it. Then here AB to the vertical angle alpha. AB to the vertical angle alpha. Thereafter you can find corresponding angle using just geometry. Complete that. Make a statistic question එකයි simple harmonic question එකයි මම ඒ lesson දෙක කරාට පස්සේ discuss කරන්න ඒ questions දෙක. Okay, complete. එතනින් ඒක දැනට ඉවරයි.